Hey, good morning. Today we're going to take a look at the next lesson, which is 6 and 7. We're doing two together. Sorry I can't be there with you, but we're going to do this the best we can anyway. Our learning targets and success criteria are to be able to write similarity statements, know the definition of similarity, and relationships between our corresponding sides and angles in similar triangles. So you will know you're successful if you can explain the definitions of similarity in terms of dilations and rigid transformations in both of those, and be able to justify why triangles have all corresponding pairs of angles congruent and all corresponding pairs of sides in proportion. So if you'd like to think in your own words, what do you think we're going to be doing in this lesson today? Well, one thing we're going to do is take a look at some miscalculations. What's wrong with this dilation? When you look at this, you see that GHFE is not a dilation of ABCD. And hopefully you go, well, obviously it's not. One is a square and the other one's a rectangle. But how do we explain that? And one thing you want to remember is we talked about the concept of collinear. When you have a dilation, when you are dilating any figure, and we want to start basically with a point. If we were going to dilate point B with P as the center, when we extend that line out, notice that E is not falling on that same red line. The other thing would be true if we go from P through C. So again, when we do any dilations, the dilated point should end up on the same line as the original P to C or P to B. So that's one way of noticing that actually F should have appeared somewhere on the gold line, E should have appeared somewhere on the red line. And notice that P, A, and G, those are all collinear. P, D, and H, those are also collinear, which means they're all on the same line. In this next activity, you want to sort your cards into two categories, and you're going to need to be ready to share what those categories are that you're using. Now, I did mine. I shared mine. These to me all look like dilations. The three on the bottom, they look like there is a dilation going on. The other ones are not necessarily a dilation. They're congruent, which you could say is a one-to-one dilation, but these have a dilation where they're actually changing sizes, and the ones on top do not. Now, for the next four slides, you're going to do work in groups, and I do want you to take a few minutes so you can pause the video. If your last name begins with the letters A through F, that's A as in alpha, F as in frog, you're going to do slide number 6. If your last name begins with the letters G through L, you're going to do slide number 4. If your last name begins with the letters M through R, you're going to do slide 5. And then the rest of you, S through Z, if your name ends with S through Z, then you're going to do slide 7, except for fifth hour students, and everybody has to do slide 7 because there's no one who has a last name that begins with S through Z in fifth period class. So all of you have to do 2. Anyway, take a few minutes, and I want you to come up with how you would do the translations there. It's asking you to translate, write a sequence of, not translate, transform, write a sequence of transformations that's going to take one figure to the next. And each of you have different figures. So if you would do that, take a few minutes. You can pause the video. And when you're done, just share with somebody who has the same last name as you do. Okay, then moving on to the next slide. Here is another match where we are going to say, okay, what is the dilation and the scale factor for each of these? These are our 4 previous cards that we were looking at, and I have them listed under, sitting under each of the cards that coordinate with them. So the first one, 2/3, and you may say, how the heck did you get 2/3, Leipold? Well, I divided 5 by 7.5, and if you do that, you find that it's 0.66 repeating, which is 2/3. scale factor 1 to 1. So these are congruent. So that means our scale factor is 1. 3/4, again, we did 3 over 4, which gives us the scale factor of 3/4. And this one, 3 over 12 is 1/4. Okay. So basically, what we want to remember is that for one figure to be similar to another, there's a sequence of rigid motions and dilations that takes the first figure onto the next, the second one, and that is our definition. So on the right, we want to learn how to read these new symbols. Remember, geometry is very symbolic. So we read this to say triangle ABC is similar to, that symbol means is similar to, triangle FDE. And remember, when you list the angles or a triangle, each corresponding angle must be in the same order. So in this instance, A corresponds to F, B corresponds to D, and C corresponds to E. All right, alphabet soup. Now we're mixing it up. So here it says, write a similarity statement about the two figures. Try to do this before you read my answer. So triangle, what is similar to triangle? So I put down, I chose ABE, and in so doing, I then have to choose is similar to QRT. If you chose a different order, for example, if you said EAB, then you have to say TQR. Okay, so keep that in mind. And then it says, explain how you know they're similar. Well, I know they're similar because I noticed right away that the corresponding angles have the same symbol in them, telling me that each of those respective angles are congruent. Then I had to do a little algebra, people, and I said, okay, I like having the fraction part, so I put 6 over 15, 3.2 over 8, and 6.8 over 17, and set up those fractions. And what I found is when I did the division, I did 6 divided by 15, 3.2 divided by 8, 6.8 divided by 17, and what I got was 0.4 every time. Okay, so you want to make sure that that you get the same ratio each time. Okay. Here we have nested triangles. So this is another example of similarity. And so we're going, what do we notice? What do we wonder? Well, we notice that the smaller triangle ADE is embedded within the big triangle ABC. And we wonder if it might be similar, if there might be some similarities going on here. So I just noticed that the triangle appears to be similar. ADE appears to be a dilation of ABC by a scale factor of 0.25 or 1/4. And how did I get that? Well, I took 3 divided by 12. Remember, it's this AD over the entire section AB, which in this case would be 12. So 3 over 12, 5 over 20, and then the third one is 4 over 16. We don't have to add those two together because DE is not part of the segment BC in this case. So in each case, we have 0.25, which tells us that this would be a dilation by a scale factor of 0.25 or 1/4. All right, this next section you have to sketch, and it took a little time for me to do this, I'll be straight up, but you want to try to sketch two triangles and try to make them so that the angles and the segments are, the corresponding segments are the same proportion, they're in the same proportion. And I did use the angle tool as they're suggesting. You want to label the triangles ABC and DEF so that A corresponds to D, B corresponds to E, and C corresponds to F. And then once you do the labeling, you want to label not only the points, you want to label the angles, you want to label each segment, and then check your ratios and see if the ratios are the same. Now, I will tell you straight up, they'll probably be off by a little bit. Mine were like 0.647, 0.648, and 0.649. But in each case, that would round up to 0.65. So So yeah, it's using the same basic scale factor. Remember, we're using technology, which is slightly off on occasion. So just do your best and see what you can come up with. So you want to share that with your group. You can, the same groups that you were in before, just share them and try to come up with a sequence of rigid motions and dilations that will take that triangle then onto the other. So if you had one like this, what would you do to take this triangle, the red one, onto the blue one, or the blue one onto the red one? Either way, but give yourself and your group. You work together as a group and come up with a set of um, motions that will take one rigid motions that will take one triangle to the other. So, how, in your own words, would we share or explain that two triangles are similar? And I do want you to write this out and submit it to me or be ready to share it with me. How do we know for sure that those things, those two triangles then are similar, not congruent? And then what is our definition of similarity? In this case, is it if there's a sequence of rigid transformations taking one figure onto the other, then they're similar. If two figures have proportional side lengths, then they are similar. If there's a sequence of rigid transformations and dilations that take one figure onto another, then they're similar. If two figures have the same angles, then they are similar. Okay, I'm hoping that you understand that it's number 3, that if there's a sequence of rigid transformations and dilations, before it was just rigid transformations for the congruence, but now we're talking similarity, so it includes the dilation. One can be slightly smaller, slightly larger than the other. Now, this is one thing we're going to talk about on Friday also. I want you to think about this. Determine if these statements must be true, could be true, or definitely cannot be true. Congruent figures are similar. Similar figures are congruent. So again, these are converse statements. So congruent figures are similar. The converse, flipping it around, all similar figures are congruent. If it helps to draw some pictures, use the space over here, but then try to explain that. We'll talk about it on Friday. And then the last one, it says, hey, Lynn knows that angle 1 is congruent to angle D. She claims that triangles ABC and DEF must be similar, but we want to convince her that it's just not there. And this one, I hope when you actually look at the numbers, you see pretty straightforward that this is not difficult to notice that, hey guys, we have the blue segment on AB is 4. On DC, it is 8. So that means we've doubled it. So we've taken AB times 2 gives us DE. Okay, so let's move on to the red section. Okay, so the red one is BC is 7, but the corresponding segment, which would be the second largest, is E to F. Well, E to F is 13. 13 is not twice 7, so no, we don't have to go any further. But if you chose to do the yellow one first, and you said, okay, well, 10 and 19, well, 19 is not twice the size of 10. So no, it doesn't work either way you look at it. And then we want to finish here again is just the definition. Make sure you have this in your resource document, that you have filled out the similarity definition. And if you need this picture in your notes, go ahead and put it in there just in case you get to use it on testing or quizzing. You guys have a great rest of your day. Make sure you do your very best, and I'll see you on Friday.